Boop. Look at that. Fancy Zones. It's a power toy, Windows power toy. Lets me rearrange things, and I've got preset regions, which is really, really great for developers. So that's pretty cool.
You can write winget install terminal, and that'll install the Windows terminal.
Oh, fantastic. I love it. Winget install terminal. Oop, oop, oop. What? Impress me with your 3D, but oh yes, I love an ASCII progress bar. That's cool. Okay, that was it? All right, let me try this again then. So I'll run it again.
Mm-hmm.
Sweet.
There you go.
That's hot. Okay, run that. What? You had me install a 1.0.
Yes.
Is this a real 1.0? Like ready for enterprise? Like everyone install this on your machines ASAP?
Yeah, 1.0 came out today, so you can just go get the full Windows terminal, no preview. So let's open Ubuntu first. Okay, so first thing I want to do, let's go to your home directory, and then we can just open the file I have in GIMP.
Dork.png, thank you.
Mm-hmm.
So hang on, the GIMP is it's a graphical app.
Yep.
Are you making graphical applications work in, oh my goodness.
So this is a preview of graphical applications working in WSL2. Ooh. So we're running GIMP on the Linux side.
How do I have Tux in Windows Explorer? And this isn't even the Pro Windows, I'm on Home.
Yeah, so WSL2 comes with a few different things. So you can have Linux Open Explorer. This is the file system integration piece. Mm-hmm. And then since you're running Windows Home, Docker Desktop also works on WSL2.
Really? Okay, so that means I can use Windows Home as a dev, put on Visual Studio, Docker, WSL2, and just party, and I'm still on Windows Home.
So mention the bot again, get its attention,
code
and then
conversations. Beep, beep,
yep,
beep.
and then throw the code in there into a code snip.
Done. Run. Mm-hmm. Okay, it's thinking, something's happening. Teams is teamsing. Ooh. Oh, that's cool. Okay, so all the console.write lines output, and it looks like, it's like a card deck. That's cool. All right, I mean,
yep.
It's cool. I'm impressed. Like, I'm not not impressed. It's just like console.write line though.
Yeah, I mean, you can get a little bit better with this. So the code I gave you has a formatter included. This is part of .NET Interactive. So you can run just deck in a code snip, and then code conversations will handle it appropriately.
Ooh, okay, deck. So I see the deck is the variable that the deck is held in. Cool.
Yep.
Got some more to run. Let's do it. Ooh, your output is too awesome. Open viewer. Ooh, .NET Bot cards. I see you shuffled the deck and visualized the deck. So the formatter tells it how to show a deck. This would be great for folks to learn how to code and when they're just getting started, and then you can like graduate into Visual Studio. That's super fun. So what we just saw was Windows Terminal. That's Windows Terminal 1.0. It is now generally available. You may already actually have Windows Terminal because if you got it in the Windows Store, it was automatically updated. And if you want to learn more or download it now, you can go to aka.ms/terminal. Remember, it's fully customizable and it's open source, which is pretty sweet. Also, we saw the Windows subsystem for Linux. This is WSL2, now generally available. That's near native Linux performance with a real Linux kernel, which is pretty amazing. We saw it integrated into Explorer, and we saw a preview of the GUI support. And this is interesting because you've got the general availability of WSL2, like start using it in your enterprise, update to Windows today, it's great. But if you want to get on the fast train, the innovation in the space of Windows subsystem for Linux continues. We're going to see a little bit of GPU support later in this conversation that we're having together. And again, that GUI support, lots of cool stuff happening in the WSL2. Oh, as well as a streamlined install experience to make getting WSL2 even easier is coming soon, which is pretty sweet. And I was able to set up my machine with Kayla's help using the Windows Package Manager, winget. This is really cool because it's open source again. It's going to be hosted, the repository, in GitHub. Set up your machines in one script, supported, secure, and we're going to work with folks like Chocolatey for an integration story. So you can take a look at that at aka.ms/winget. So how are things going at GitHub? I know that you just acquired NPM, which is pretty sweet.
Yeah, it's super exciting. It's been incredibly busy. I mean, we were incredibly excited and honored to get to work with the NPM team. I mean, NPM is the biggest software registry in the world. There's over 1 million packages in it. It gets over 75 billion downloads a month, which just blew my mind. It's incredible. And, we have huge overlap between the NPM and GitHub communities. 96% of all NPMs host their source code on GitHub. And so there's a lot of opportunity to make sure we continue to serve all the NPM users and do a good job for them, but also to integrate it well with GitHub and provide things like end-to-end security and traceability, which we're excited about too. And so, yeah, it's really fun. JavaScript is a big language ecosystem, so it's a lot of responsibility, but lots of good stuff we can do. The model in the past for GitHub was pay for privacy. So all the public repo stuff was free, but then if you wanted to do any private work, you had to pay for it. We made the decision to make GitHub free for everyone, basically. And so now anyone can create private repos and private organizations and add an unlimited number of people to them for private work without paying anything. And then, of course, if you're a big company, if you're an enterprise and you need really advanced compliance and security, you pay for that. That still costs money. GitHub now has a mobile app for iOS and Android that you can use that we just put out a few weeks ago. And it's pretty cool.
The convenience of being able to have GitHub in your pocket is awesome. And so we rolled out GitHub sponsors in November, so like just less than 6 months ago, as a way for you to contribute money to the people or the projects that you admire, or maybe that you even depend on in the work that you do. And already we've paid out millions of dollars to thousands of developers and maintainers around the world. And we've got hundreds of people who tell us they're depending on GitHub now to make rent.
Cool.
So let me go ahead and switch over to my GitHub application. So here you see a repository, which is the Olive tracker. It's one I've been building while I've been at home in my spare time, keeping track of where Miss Olive has been. And it's great because you can see I can check on pull requests. If I had any issues, I could check on those. No issues because my app is perfect. And it's great because it helps me stay connected. So for my Teams repo, I can check on issues. I can comment on pull requests and just stay connected even when I'm on the go, like when I'm walking Olive.
This is like a day worth of startup instructions. This is real typical, though.
It's very typical. But with code spaces, we've got a much easier way now. Scroll all the way up. You've got that green code button. So click on it. And then opening code space.
Ooh.
Yeah.
Okay.
All right. So here, we are opening your code space or building it for you right now.
Okay.
And it's going to take care of all those instructions on a remote environment or code space. And then we're going to connect you to it in the browser. So basically one button is all you need to get started.
So this is like a development specific container in the cloud. And here we go. This is Visual Studio Code.
Yep. Looks familiar, right?
It does, but I'm in my browser. This is cool. All right. It says opening remote.
Yep. It's still got a little bit of setup to happen here. Obviously, building a code space takes a little bit of time, but far less than all that setup.
Certainly different between taking 7 hours to set up a machine from scratch. We're here complaining about this took like 20 seconds to set up an entire environment, unacceptable. This is amazing. So it looks like it's done.
Yeah, it's done. You can go ahead and close that creation log so we can reclaim some space.
All right.
And themes are always super cool to have, right? This should look like your VS Code. All right, so go to that gear icon and we're going to turn on preferences sync.
Turn on preferences sync.
Yeah.
All right, turn
it's in
on.
Preview, so they ask. Let's just sync settings.
All right, so I'll sync my settings. Turn on. Oh, here we go.
Yep. We remember your GitHub login, so all you have to do is select it.
This is the first time.
And replace local.
All right, cool.
And then it's syncing it.
Whoa, hey, my theme. This is my theme. Dependabot is like a person that works for you, that watches your dependencies, and it will go and do pull requests. So like here, Dependabot went and noticed that the MongoDB dependency bumped from one version to another. And what I love about it is it will go and pull the release notes out. It'll basically do an inclusive, like I want everything from this version to that version, and it copy pastes it in. You can even go and see each individual commit between these two versions. And it's lovely. And then you can go and do, and look, I'm doing a merge directly inside of VS Code, inside of Codespaces.
Yep. It's basically like you're working local, but from a browser.
That's so awesome. Okay, well, wait a second. If I'm working local from a browser, how do I run this thing though?
Yeah, so go over to your debug extension there.
All right.
And just go ahead and click the run button, or you can use any of your shortcuts.
Okay. But this is going to be like localhost 5000 or something. How is that even possible?
So what we do is we actually have a port forwarding service that is going to take that local host on the code space
localhost
and
3000.
actually forward that to your local browser.
Sweet.
So if you go ahead and open that.
Do I literally open localhost?
Yep. Go ahead and follow that link.
That seems impossible. Whoa. Connecting to the forwarded port.
And then you'll get to see the Olive tracker for real. So go to the live share extension.
This one.
Yes.
All right, cool.
Perfect. And there, my name is all lit up. So you should just be able to invite me directly.
Okay, invite. Starting collaboration session.
Awesome. I got your notification in Visual Studio 2019, which is what I'm on.
Mm-hmm.
And I'm joining right now, as you can see.
So it is Visual Studio in GitHub Codespaces in the cloud.
Well, I'm on Visual Studio connecting to your Codespace in the cloud through live share.
I see. So anyone can use the tool that makes them happy. I'm in my browser. Oh, and you're actually selecting stuff, and you can see my selection as well.
Absolutely.
See, I'm going to use live share all through this whole thing today. This is fantastic.
Yep, it's a great way to collaborate, and we're so happy that it's enabled people to really connect virtually, even when we have to be apart and physically.
Very cool. I think I actually have a slide on Codespaces, and we can learn about how people can get this right away.
Awesome.
Here we go.
Yeah. So if you'd like to try out the experience, well, you've already tried it out, but if you have any friends who want to try it out, they should sign up at that link right there for the private preview for our GitHub integration. But if you don't want to wait for a private preview, you can actually try out Visual Studio Codespaces right now.
Visual Studio Code has over 21,000. Can't really move that window. Has over 21,000 extensions, right? You can develop locally, remotely, or in the browser, as we just saw. One of the best parts is that you can synchronize all of your settings and all of your extensions across anywhere. So your dot files, your aliases, your extensions, the way that you work is the way that you work, synced to the cloud and available anywhere, which is pretty awesome. The other thing that's worth pointing out is that .NET Core 3.1 continues to march on. So many people are using it, and it is in long-term support. That means that you can do work, start a new project on .NET Core 3.1 now, and you will be supported for years. We've added WPF support, Windows Form support. You can have side-by-side, so different versions of .NET not affecting each other, as well as self-contained EXEs. So you can put your own personal copy of .NET into a folder, and it will just work on any machine. And then, of course, the modern web UI with ASP.NET Blazor. You can check that out at .net.
It's a Xamarin Forms project, so all of his UI is actually shared. It's in XAML right here, and it's in this .NET Standard project, and he's targeting Android and iOS, you can see, which is cool. But I can also add things like TVs, windows, a watch if I want to. And in my Xamarin Forms app, because like I said, all my UI is XAML, I also get all of the great Visual Studio features that I expect. Like if I start scrolling down here and typing, I'll go to my grid, space. You see those little stars that pop up? That's IntelliCode, which is cool. What? Am I going? Scott, are you? Oh my gosh.
I'm sorry. I was, while you were talking, and I kind of was exploring, and I was kind of messing around.
I see you're really paying attention.
So wait a second, though. I pushed save on Visual Studio Code on my machine, and you didn't even recompile, though. How is this happening? Are you in the middle of a session? What is
Yeah, well, there's a couple of things happening right now. First of all, my iPhone plugged right into my PC. It is debugging. And that's using something called hot restart, which lets me just like really quickly rebuild and redeploy right to the phone. But you're actually triggering a XAML hot reload when you change the XAML here. So I'll go and I'll change this to the superior color, pink.
Oh, wait, hang on. That's your iPhone on this left there? Like
Yeah.
mirrored?
Yeah.
Ooh.
Isn't that cool? Very fancy. So it's convenient when I'm trying to work from my kitchen island because all I need is my iPhone and my laptop, which is pretty cool.
This is footage of my dash cams, okay? I am a big fan of dash cams.
Cool.
So this is like me driving in my town, and it's just raw footage. I've got a bunch of this stuff. What I care about, though, is this NVIDIA GPU is completely OP. This is actually a GeForce 1660 with Max-Q. We're going to watch this because I'm looking at all the different engines. I want to use the CUDA engine. And what I've done is I've taken that raw footage. I'm going to go into WSL2. Now, this is WSL2. In the future, the fast ring will have this GPU support. So what I'm going to do is I'm going to run TensorFlow under Linux on this machine, okay? So right now I'm running it on that video. Now watch the GPU. We're using the GPU here to do that work of that detection, right? For that autonomous vehicle. This is super awesome. Check this out. Look how hard the GPU is working to make that happen. And look at the GPU usage on the memory, almost using all of that 6 gigs. This is fantastic. Now I'm going to stop that actually, and let's just look at the resulting video. Here's a resulting video. Look at that.
With Teams extensions for Visual Studio Code and Visual Studio IDE, you can take Teams application development tools to directly where you already work. You can pick the type of Teams app you want to build and then build it. You can create a manifest and package your file, validate it, and with a single tap, you can test your application in Teams across desktop and mobile. Once you're ready to publish your app, you can either publish your app to the global Teams App Store, making it available for all the Teams users, or if your app is just for one organization, you can submit it to your IT admin directly for their approval.
I want to show you all 2 things today. First, how easy it is to build natively multi-user apps with Fluid Framework. And second, how you can embed and share your live web experiences everywhere with the help of Fluid. We architected Fluid for super low latency distributed systems, and yet I have never made more impressive web apps more quickly. We created a set of distributed data structures with the merge logic implemented in the client.js that handle the difficulty of distributed data merge for you. For a hackathon we recently ran, I wanted to build a simple hack tracker to manage all of our incoming projects. The hack tracker has a list of our products to the left and a message board to take notes in the middle. I built this very simple application with React, but of course you could use any front-end framework. While our app lets me take notes locally, it's not wired to anything yet. I also can't share my notes or interact with coworkers during the hack week. It's easy to add all of this functionality with Fluid Framework. Fluid distributes server-side data and logic to the browser and gives me access to distributed app state locally. Again, there's no server needed. These 2 attributes, combined with our component model, will make upgrading our hack tracker much, much easier. It's just waiting to be wired up. By replacing this JavaScript map with a Fluid shared map, I can quickly bring the application to life. I also have to listen to events on our shared map so that I can update our project list with changes from other users. Now we can reorder and add new projects collaboratively. I'll have to write 2 code snippets here, about 100 lines of code total. One to take changes from other users and replicate it into Draft.js's editor context, and another to take our editor's context and replicate it into Fluid. This is similar to the project list. We need to change the distributed data structure state locally and then listen for changes from other users. I also included some model adapter code. Now we have live notes during our hackathon week, built using Fluid and excellent open source tooling. We'll support embedding of Fluid components across M365. For example, I can paste my hack tracker into Teams and share it always up to date with everyone in the hackathon. Fluid Framework SDK will come with all the tools you need to make your own collaborative applications. but it also has a component model that makes it easy to reuse and embed your live Fluid parts within other Fluid-enabled web apps. As you can see, we had a group of amazing projects during the hackathon week.
Let me show you how Dan and I use Fluid Framework across the Microsoft 365 ecosystem. I'm writing an email to follow up on next steps. I can pop open this new menu of collaborative Fluid components that's available to me in Outlook and Teams. These components are all built on the Fluid framework that Sam just showed us, so his component could appear here too. Many of these were designed with specific user intents in mind, like action items.
And in that email I just got from Maya, I see she's editing, and it's easy for me to edit too, right here in Outlook.
Now I want to share the action items with another group of people. In this case, we use Teams for quick collaboration, so I can paste the action items right here in our chat. And because we're reusing a Fluid component, we have a single source of truth, no matter which app or device people collaborate on. And it looks like everyone's jumping in to contribute.
Now, over the last couple of years, we've been breaking down the barriers between Win32 and UWP. We're expanding this effort even further now and finally giving it a name, Project Reunion. Today, apps generally call directly into APIs in Windows, whether they're desktop Win32 APIs or UWP APIs. With Project Reunion, we're making many of those same Win32 and UWP APIs available in a better way by unifying the existing APIs and decoupling them from the OS. This allows you to mix and match from the APIs that work best for your app and adopt new capabilities on demand. You can also unlock the latest APIs without waiting for your users to update their OS. We're going to do the heavy lifting by polyfilling gaps down level as needed, and we've already begun with APIs like WinUI 3, WebView 2, and MSIX. In fact, I'm proud to announce we have new previews of WinUI 3 and WebView 2 available today. Here I'm building a sample app for farm management. This could be any Windows project, UWP, WinForms, WPF, React Native, or C++. But I chose to use an existing desktop app. I also wanted to just update the user experience and not the underlying business logic. So all I need to do is add the NuGet packages, and the APIs are pulled from those instead of from the platform SDK. So in this specific instance here, I'll expand my packages. You'll see I have WinUI, I have WebView 2, and I have some packages here that allow me to use .NET with these APIs. Now, these packages include the same APIs as the platform SDK, so your code doesn't have to change. You also get to release the app to all versions of Windows 10 like you did before, since it is decoupled from the OS. You'll see here, when I launch it, it gives me this great animation. It'll automatically log me in, just like I expect. And then I'll go and I'll see a list of the farms that I've been working on. Click one, and you see all the details are laid out in a more productive and easier to use experience. Microsoft Graph and Microsoft Search draw unique connections between your people, files, and tools. And because Search is integrated in Windows, you can find these through a familiar interface. For example, Carol showed me some information the other day in the sample farm app, but I wouldn't always remember which app or dashboard. Normally, I'd have to ask her. But now, I can just search for Carol, and the graph knows that this is the Carol I work with, so she shows up. I can see her organization, her office location, and even the files that we've been working on together. There it is, the file that we were working on that she told me about. I can click on it, and it relaunches me right back into the application at the dashboard we were looking at. You know, I wanted this user experience to be productive with touch, mouse, keyboard, and pen. So for example, I can go swipe, and I'll be able to go and swipe this other one, and there you go, I can go change it. I can also go and edit the fields and use my mouse and my keyboard to be more productive when entering data. So here I can just tab around, tabs nicely. I also can get inline input validation. So for example, I'll just change the location to something that's invalid, try to hit save, it'll tell me the address is wrong. So as you can see, I'm writing the UI layer in .NET, but more specifically, the latest version, .NET 5. However, my business logic was written as a C++ ATL COM object that I could have written 15 years ago. And I'm able to reuse it here without any modification, allowing me to focus on the user experience. That compatibility is one of the promises of the Project Reunion model. Now, to get that great swipe capability, here let me go to the stage control, And yep, I've added the swipe control, and I have 2 items that show up on each one of these stages. And all I had to do is I have done and start, and I have 2 different event handlers, here and here, and I'm done. Everything else built right into the controls. Same thing for the number box. If I want to go get all that great mathematical expression, all I have to do is change one property saying accept it, and that will work. Let me show you how the WinUI experience in my sample app adapts when running on an iPad. Here you'll see I'm running the exact same app that I was running on my desktop before, except it's now adapted to the 11-inch iPad. So it reflows the content on the right-hand side to look more natural. I can scroll and see I have all the same widgets. I also get to use all those great swipe controls just like I would expect before. Now I also get the ability to use my cameras and my microphones and other peripherals so it feels natural for me on this device.
The app I'm about to show you is based on a common app architecture for modern cloud apps, a static web app, aka a SPA, backed by some serverless APIs. I used pre-built services in Azure to complete authentication, video transcription, geospatial services, and storage, and plugged them into my app as Azure functions. The result is a geo-distributed serverless web application. I can quickly scaffold this Azure static web app in the portal initialized from a Git repo. That then creates a series of GitHub actions to set up continuous integration and continuous deployment for me. If a new developer wants to contribute to the app, with Azure, they can get a dev box set up in seconds and access it from any device.
Azure Functions is our serverless offering that allows your code to scale up or scale down on demand. But don't worry, you don't have to configure the functions. We're going to use conventions instead. Just put your code in the API folder, and static web apps will turn them into Azure Functions for you. Let me show you the app. This is Sunrise Standup. It's the app that we use because our team is globally distributed and working remotely so that we can see what everyone's working on. You can record a short video and tell everyone what you've been up to.
Hey, Thomas here. Everything is going well in Switzerland. Today, I redeployed my Azure Lab environment, tried out Azure Static Web Apps, and created some awesome content for Microsoft Build.
All this code is sitting inside of a GitHub repository. And there's the API folder I was telling you about, where you put in your code and we'll turn it into an Azure function for you. Click on Create Resource and search for Static Web App. Now simply click on this tile, click on Create, and then fill in the form. Now I can go ahead and click on Create. In the background, Azure and GitHub are working together to make sure that I have a GitHub Actions pipeline. GitHub Actions is a workflow automation engine that's built into GitHub that allows me to create CI/CD pipelines. Now what I'm going to do is simply click on this URL and navigate to our application that is now running in the cloud. The GitHub Actions have run and safely deployed our code into production.
Now what you can see here is that I already have the Azure Static Web App in my Visual Studio Code instance, and everything's defined by convention. So I have all of the APIs under this API folder. Get GitHub Avatar, get SAS Token, get videos. And as you can see, I'm already running everything locally on my machine so that I can iterate really quickly as a developer. And I can actually run the Sunrise Stand-Up app right here. I can go ahead and play this.
Greetings, everyone. Brian Ben's here in Las Vegas.
All right, so he's in Las Vegas. Let's go see if we can see him on the map. Unfortunately, no dice. There are no pins on the map, so we need to fix this. Let's go back to our Visual Studio Code instance. All right, so what you can see is that I have this application in Visual Studio Code, but what's really cool is that if I install the Azure Static Web Apps extension into Visual Studio Code, I get some really key functionality in a few important spots. Now, one of the areas that I get additional functionality is if I go into the Azure Viewlet, you can see that I have the Static Web Apps Viewlet right here. Now I need to add the additional API endpoint. So all I need to do is to click on this lightning button. Now it's a lightning button, maybe because it happens really fast, so pay attention. I just need to create a new endpoint, get locations for the name, and you can see that it actually scaffolds out a new function for me right here. And it does everything on the back end as well. So all I need to do then is just replace this with the code that I want to write. Okay, so now that we have that code written, we want to see if it actually works. So let's go back and look at another spot that the extension adds some pretty cool functionality. In addition to being able to launch the node functions, I can also launch a full stack application with the Azure Static Web Apps application, which launches both the back end with the functions as well as the front end for the full stack app. So I'm just going to switch to that and we're going to start debugging. Cool. So now we actually have the Azure functions running right here. So now let's go look at the app again and see if it's working. All right, cool. So now we can see that the pins are actually loaded and we can see Mr. Benz from Las Vegas. So I can just go ahead and create a new pull request. It'll automatically be populated by my commit. So I can choose master, add map endpoint, and that will create a new pull request. Now, all I need to do is just add Donovan as one of the reviewers to this pull request. Click OK, and he should get the message.
This is a pull request notification coming from Microsoft Teams thanks to the GitHub app. As we can see, Amanda completed her changes, and I can click on this link and jump right to them inside of GitHub. A PR allows me to review the code before I merge it into master. Reading the code is one thing, but running the code, that's even better. But I don't have all the tools that I need on this machine. Luckily, Azure Static Web Apps has me covered. I simply click on the link that's automatically added to every pull request that allows me to see the code actually running in a staging environment. And luckily, Codespaces turns any web browser into a development machine. Even this old machine that I use in the garage, it has no development tools on it, and I installed Linux on it just for fun. But I can actually use Codespaces to develop. Clicking on this link is going to spin up an entire development environment for me in the cloud, far more powerful than the machine that I'm holding. It's going to have Visual Studio Code on it. I can install all my favorite extensions, and all the libraries and frameworks I need will automatically be installed. Now that my environment is spun up, I can do what I would normally do. I can open the file that I want to modify. I can go ahead and import the dark theme. And just like I would if I was upstairs, I can simply click on debug. Doing that is going to spin up all of the functions, which is the backend that we talked about earlier, and the changes that Amanda just made. Then I can click on this link that's going to allow me to see my changes right here in real time. I could set breakpoints, I could step through the code, but as we can see, the dark theme was applied correctly. I can commit this code right here from the web browser and go about my business trying to fix my car.
Power Apps is our low-code platform for developers and citizen developers to build rich applications quickly and easily. Power Apps is a low-code environment to write apps for both web and mobile. So I want to show you how we can use this to build an application. And we're going to build an app inspired by how we've seen our users leveraging cloud-native tech as part of the COVID-19 response. The mobile application was built using Power Apps, and it's calling data and services that's running in Azure. I can create a brand new ASP.NET app. I'm going to select the Web API project. Now I need to get this API connected to that Cosmos DB database. And the new connected services experiences is just what I need. I'll go ahead and select to add a dependency here. I'll select to add Cosmos DB. Visual Studio is connected to my Azure account, so I'll select my database. It's pulling in the connection details for me. I have the simple configuration option to choose to either store these details locally in a secrets file or securely encrypt them within Azure Key Vault so they don't even stay on my machine. Now, once I'm connected to Cosmos DB, we can go ahead and start to write some code. You can see here, this is an example of one of our API controllers. This is for screening data, so I can get screenings either by ID or all of them. I'm actually using the .NET Entity Framework with the Cosmos DB SDK, so I have something here like a link statement. But testing APIs can be cumbersome because I don't always have a UI to drive the experience, so I'm fiddling with CLIs or other tools to try to navigate. But I want to showcase this pretty cool new tool right inside of Visual Studio and .NET called HTTP REPL. What HTTP REPL allows me to do is browse and debug my API the same way I would navigate a folder structure. So I'll start a debug session. It's going to open up this console window. You'll notice instead of being connected to the C drive, I'm connected to localhost. I can now navigate using dir, or if I want, I can type ls. It's going to return back to me the different endpoints, including our screening data that we were just looking at. Let's navigate to it and even do a get. It's now executing my code and returning that data from Cosmos DB now within my Visual Studio project. You can see here in the Power Apps Studio, I can visually create this mobile application in just a few hours. I have access to over 300 connectors out of the box, or I can use our own API, this screening API now running in Kubernetes. Let's go ahead and add some information to this screen. I'll come in and insert a vertical gallery. I can even go ahead and choose the data source. Let's choose that screening data that we've been looking at so far. I can move the table down, go ahead and resize it. I can customize the look and feel by choosing the layout. I like this title layout right here, so we'll go ahead and select that. I even have the option to choose different fields to surface. Because I published this API through Azure, it knows, hey, I have things like contact number and visitor name from this API. So we'll go ahead and select it to show the visitor name and contact number. So we've customized our form to show exactly how we want. Now, this is a full mobile app. It could run across Windows, Android, any device. You can see here, I have a number of screens here, including our main screen and that screening data form. And I want to show you how we hooked this form up to those AI capabilities that let me scan a picture. I did that by navigating here, still in the Power Apps experience, to enhance my app with AI. I have a number of capabilities at my disposal, like object detection. I want to go ahead and choose form processing. We'll give our model a name. It's going to let us upload a few sample images. And after I upload a few samples, it's going to create and train a machine learning model for me. Without having to write any code, I can now come back over here to Power Apps and tell it, hey, if someone clicks the scan button, go ahead, call that forms processing model. I can now map this to those different fields and do all the typing for me. So our app looks pretty good now, and I just need to publish it to get in the hands of our users. And our team, just like the 75 million others out there, has been using Microsoft Teams heavily during the COVID-19 crisis. And with new capabilities, I can now go ahead and choose to take any Power App and instantly add it to my team. By clicking this button, now my application has been deployed to whatever teams, whatever channels, or my entire organization. So now everyone using this Teams app has access to it, instantly deployed. So let's open up my phone again. I can select to see the apps I have here, and there's that COVID screening app integrated in the Teams experience, in this case on my mobile device. I can go ahead and open it up, and I could start to conduct those screenings.
Welcome, Synapse Link. With a single click, I can enable Synapse Link on my Cosmos DB account and select a Synapse workspace, an existing one, where my analytical queries will be run. Now, behind the scenes, Synapse Link created a live, optimized columnar representation of the Cosmos DB's operational data and made it available to Synapse without impacting the performance of Cosmos DB's transactions. Here in my Synapse workspace, I can bring together all my enterprise data integration, data warehousing, and big data analytics into a single unified experience for my immediate BI and machine learning needs. Let me enter the Data Hub. Using the Data Hub in Synapse Studio, I can access all my data that's being managed by Synapse, including files, tables, datasets, etc. I can also access the real-time data that's enabled through Synapse Link from Cosmos DB. With a simple right-click, I can create a new SQL script or create a notebook to run a Spark job on my live Cosmos DB data. Let me go ahead and bring up a SQL script that I wrote earlier that essentially gets real-time failure rates from the Cosmos DB feed. You'll notice that when I rerun the script, the timestamps get updated. The view that you see in the result set is not from last week or yesterday or even the last hour. The view that you see is from what's happening right now, which is really cool. Now we've deeply integrated Synapse with Power BI, which enables me to create Power BI reports and enterprise-grade semantic models right from within the Synapse's workspace. Now this is the dashboard that's being backed by the Synapse SQL query that you just saw to get the failure rates. Let me go ahead and refresh this Power BI report to get real-time insights. Now our business users can rely on this dashboard to deal with incidents as they happen in real time. Now as you can see on the screen, the failure rate for some of the parts is higher than the expected threshold. Let's figure out how to go handle this problem. Now, using the data flows in Synapse, I've already ingested the stock levels and prices from all our suppliers in our SAP system and supplier contracts and delivery terms from our Dynamics 365 system. Now, to mitigate the current situation, we need to find a supplier to source the parts whose failure rate is above the acceptable threshold. To predict the next best supplier, I need to join the Synapse Link-enabled live data from Cosmos DB, which has the list of the bad parts, with the supplier data from Dynamics 365 and the stock levels and the pricing data from SAP, and run a predictive analytics query across the combined data set. The SQL query that you see on the screen captures this logic. Now, one of the things that I want to showcase is the use of the predict function in the SQL query, which allows us to apply a model that was created in Azure Machine Learning to score against the combined data set. Let me go ahead and run this query. Now, in the results section in a few seconds, you're going to see a ranked order list of suppliers that meet our requirements. You know, I'm not a data scientist, and Synapse made it really easy for me to do predictive analytics by leveraging the model that was created in Azure Machine Learning to get the results, the predictive analytic results that I want. Now, let's go ahead and go back to our Power BI report and add these predictive insights to this report so we can share them with our business users. Doing that is really simple. Just a few little clicks to add the insights that we want. I go ahead and click here and get the high value. And that's it. When I go ahead and click Save, these new predictive insights have been added to the Power BI report and shared with all the business users. Now, they can go to Power BI online and double-click to understand more details of how the prediction was made, what elements of the machine learning model influenced the prediction decision. It gives them a little bit more insights, deeper insights into what happened behind the scenes.